Let us see the drive motor characteristics. In this drive motor characteristics contains mechanical speed characteristics of various types of load and drive motors, braking of electrical motors, DC motors with shunt series compound classification, single phase and three phase induction motors. Come, let's see this DC motor characteristics. It includes torque and armature current characteristics, speed and armature current characteristics, speed and torque characteristics. Before that, we have to see motor classifications according the type of DC motors. Already I told the DC motor contains three main classifications. That classifications are shunt motor, series motor, compound motor, include of compound motor, long shunt compound motor and short shunt compound motor. This picture says a DC shunt motor explanation oriented drives. DC shunt motor always, the shunt motor field winding is connected in parallel with the armature shown in the figure. The field current ISH is constant since the field winding is directly connected to the supply voltage V, which is assumed to be constant. Hence the flux in a shunt motor is approximately constant. This is characteristics of DC shunt motor. It consists torque versus armature current, torque versus armature current, speed versus armature current, speed versus armature torque. Let us see the first classification of torque versus armature current. This graph represents torque versus armature current characteristics. Since the motor is operating from a constant supply voltage, flux pi is constant because neglecting armature reaction, so we get armature torque proportional to armature current. Hence the characteristic is a straight line passing through the origin as shown in graph. The shaft torque TSH is less than armature torque, and this dotted line shown in the figure, it is clear from the curve that a very large current is required to start a heavy load. A shunt motor should not be started on heavy load because we achieved TA proportional to IA. Next, let us see speed versus armature current. The flux pi and back EMF EB in a shunt motor are also constant under normal conditions. Therefore, speed of a shunt motor will remain constant as the armature current varies. I mentioned dotted line in the figure. Strictly, when load is increased and flux decreases due to the armature resistance drop and armature reaction respectively. However, back EMF decreases slightly more than frequency, so that the speed of the motor decreases slightly with the load line. Third one is speed versus armature torque. The curve obtained by plotting the value of speed and armature torque for various armature current, it may be seen that speed falls somewhat as the load torque increases. The conclusion of those three classifications, there is slight change in the speed of a shunt motor from no load to full load. Hence, it is essentially a constant speed motor. Then the starting torque is not high because armature torque proportional to armature current. Next, we have to see series DC series motor. This is DC series motor circuit diagram. If a mechanical load on the motor increases, the armature current also increases. Hence, the flux in a series motor increases with the increase in armature current and vice versa. It contains same three classifications: torque versus armature current, speed versus armature current, speed versus armature torque. Come, let's go with the armature torque versus armature current. We know that armature torque proportional to flux into armature current, because magnetic saturation being flux proportional to armature current. So after magnetization, pi is constant, so armature torque proportional to armature current. Thus, up to magnetic saturation, the armature torque is directly proportional to the square of armature current. If armature current is doubled, armature torque is also quadrupled. Therefore, armature torque versus armature current curve up to magnetic saturation is a parabola. However, after magnetic saturation, torque is directly proportional to the armature current. Therefore, armature torque and armature current curve after magnetic saturation is a straight line. It included point AB of the curve. It may be seen that in the initial portion of the curve, this means that straight torque of a DC series motor will be very high as compared to shunt motor. Next, speed versus armature current characteristics. When the armature current increases, the back EMF EB decreases due to some drop while the flux F increases. However, armature current drop is quite small under normal conditions and may be neglected. So, up to magnetic saturation, the speed versus armature current curve follow the hyperbolic path, and after saturation the flux becomes constant and so does the speed increases. Third, speed versus armature torque characteristics. It has to clearly says the series motor develops high torque at low speed and vice versa. It is because an increase of torque requires an increase of armature current, which is also the field current. The result is the flux is straightened and hence the speed drops. It reverse happens should the dark lines show us a parabolic, which is torque below. Following 3-point conclusion are drawn from the speed versus armature torque characteristics. I told already, high starting torque initially being in DC series motor, armature torque versus armature current, and it is a variable speed motor. It automatically adjusted the speed as the load changes. If the load decreases, its speed is automatically raised and vice versa. At the no load condition, the armature current is very small and the flux speed rises to an excessive high value, n proportional to a reverse of flux. This is danger for the machine, which may be destroyed due to centrifugal force set up in the rotating parts. Therefore, a series motor should never be started and no load. However, to start a series motor, mechanical load is first put and then the motor is started. Third main classification is characteristics of cumulative compound motor. It contains armature torque, Armature current characteristics. Armature torque and armature current characteristics says the load increases, the series field increases, but shunt field strength remain constant. Next, total flux is increased and hence the armature current may be noted. The torque of a cumulative compound motor is greater than that of shunt motor. Next, speed versus armature current characteristics. As explained above, the lead increases, the flux per pole also increases. Consequently, the speed of the motor increases, tails as the load increases. It may be noted that as the load is added, the increased amount of flux causes the speed to decrease more than does the speed of the shunt motor. Thus, the speed regulation of a cumulative compound motor is pure than that of a shunt motor. Thank you.